Hello. In this video, we're going to go ahead and start talking about applications of quadratic equations. To begin with, we're going to go ahead and start with the Pythagorean theorem. Now, the Pythagorean theorem says the following. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so first of all, we have a right triangle, which is what you see right here. For this right triangle, we have three different sides. That's what a triangle is, obviously. So in a triangle, the side that is opposite the right angle is called the hypotenuse. Now, this is the only one that must be called a certain side. So this must be called the hypotenuse. And the hypotenuse we always label as C. The two sides that make up the sides of the right angle here are called legs. But here's the thing, they're interchangeable. One could be one leg, the other could be the other leg. It really doesn't matter. So just call one whatever you want. So for the first leg, I'm going to label that A. For the second leg, I'm going to label it B. And there is a relationship between these three sides when you have a right angle. And this relationship is the sum of the squares of the lengths of the legs. Now, the sum means plus of something. So something's happening over here. And over here, it's going to be the squares of something. So something squared. Of what? The lengths of the legs. So the lengths of the legs are A and B. And then this is equal to, or just is always the equal sign. The square, squaring something over here, of the length of the hypotenuse, which is C. And this gives us the Pythagorean identity, the Pythagorean theorem. A squared plus B squared equals C squared. This is something you probably already have, you probably already know this, or at least you've seen this before, more than likely. So let's go ahead and use this particular identity. Example, one of the legs of a right triangle is twice as long as the other leg. We're going to ignore that right there. That was always a capital I, fantastic. If the hypotenuse is 15 inches, how long are the legs of the triangle to the nearest 1/10 of an inch? Okay, looking through here, first of all, we see that there is in fact a right triangle. So my recommendation is to draw a right triangle. I mean, that is a fantastic right triangle. I don't know what you're talking about. Stop making fun of me. Anyway, one of the legs is twice as long as the other leg. And what's the question? How long are the legs of the triangle to the nearest 1/10 of an inch? We need to define a variable. And so let's go ahead and begin with let and then x equal. How long are the legs of the triangle to the nearest 1/10 of an inch? We can define our variable. We only want one. We can define our variable as either the length of the shorter leg or the length of the longer leg. Ask yourself which one would be easier. If you said the shorter leg, then you're correct. So let's let x equal the length of the shorter leg. Now, here's the reason why the length of the shorter leg is easier. Because if we see this, the longer leg is twice as long as the other leg. That means that doubling our variable, in other words, 2x, that's going to give us the length of the longer leg. Notice if we had defined our variable as the length of the longer leg, the length of the shorter leg would be 1/2 x, because if the longer leg is twice as long, then the shorter leg is half as long. Awesome. So in our diagram over here, it doesn't really matter which one of these you label these as. So I'm going to label this as x and this is 2x, but it really doesn't matter. You could put this as 2x and this is x. It will not change anything. if the hypotenuse is 15 inches. Now that's fantastic because that just tells me that that right there will be 15 inches. And from this, we know a squared plus b squared equals c squared. So if we say that a is equal to x, b is equal to 2x, and c is equal to 15, that means that with our formula a squared plus b squared equals c squared, that tells me that x squared plus parentheses 2x close parentheses squared equals 15 squared. And this is very important. Make sure that you square everything here. Now, I didn't put a parentheses around this x, but it probably would have been easier to see that way. So x squared plus 2x squared equals 15 squared. And then simplify. X squared is just x squared. And then plus 2 squared, which is 4. And then x squared, which is, of course, x squared, equals 15 squared, and that is 225. Awesome. At this point, just combine like terms on the left-hand side. That's going to give us 5x squared, and on the right-hand side, it's going to be 225. And we just want to solve for x, so the best thing to do is get rid of the 5 because 5 is not being squared. So let's just divide by 5 here. And that's going to give me x squared equals, what is that? 45, I believe. Awesome. So if x squared equals 45, that means that x is equal to plus or minus the square root of 45. And you would simplify this if you could, and you can simplify this, but let's look at the question. It says to the nearest tenth of an inch. That means all I need to do is I need to approximate this. That means go to your calculator and type in the square root, the square root of 45. Doing so will give you plus or minus 6.708203932. And notice that we want to go to the nearest tenth of an inch, but here's something important. So starting with decimals, let's talk about what each of these are called. This first decimal place is not the oneths, it's the tenths. Then this one is called the hundredths. Then the thousandths. Then the next one here is called the 10,000ths. And then this one would be called the 100,000ths, then the millionths, and so on and so forth. So always remember this begins with the tenths. So the first decimal place is the tenths digit. And if we're going to the nearest tenth of an inch, that means that we're going to the first decimal place, which means we need to go ahead and cut that off right there. And notice that 6.7 is our number. We're not going to use the negative, because if you look at this, there's no such thing as a negative length of the side of a triangle. But we're not done. Since we know that the length of the shorter leg is 6.7 and the units are going to be inches because this is in inches, then doubling that, just take your calculator and multiply by 2, and that's going to give you 13.4. Awesome. And what was the question asking? How long are the legs of the triangle to the nearest tenth of an inch? That's what we have right here. So in answer to the question, the legs of the triangle are 6.7 inches and 13.4 inches. Notice I didn't clarify which one was the shorter leg and which one was the longer leg because, well, frankly, if you can't tell that 6.7 is smaller than 13.4, we have a bigger problem than, just not labeling something. Alrighty. Well, I believe that is it for this particular video. I will see you in the next one. Have fun.